Algebra I Honors, Lesson 2.5, 2.6, and 2.7. We're going to discuss statistics, displaying and analyzing data, probability with simple probability and odds, and square roots and real numbers, as opposed to rational numbers. So, statistics, displaying and analyzing data. There's two ways to plot data, line plots and stem and leaf plots. So let's look at how each one works. All right, a line plot, speeds of 20 of the fastest land animals are listed below. So we need to figure out where things go on this list. We'll start down here with 30, and we'll go up by 5s. Can I fit them all? This is the kind of thing you have to do for data. I think we're going to have to go up by that. And it's a pain. You have to erase and you have to start over, and a lot of people don't like that. You know, life can be challenging. So you just put an X here at 45, X here around 61, X here at 70, 43, another one at 45, 32, 42, 40, 50, 40, 40, and so on and so on. You just stack the data up. It's a line plot. So you can look at that. And when you're done, you can say, well, which one's the most frequent? And after you've plotted all, you'd say, oh, yeah, it's 40 is the most frequent. You could also just look at the data and figure that one out, too. So a stem and leaf plot, I'm going to have to zoom out a little bit because my page actually got messed up. Mrs. Evan wants to compare recent test scores, blah, blah, blah. So we are going to make a stem and leaf plot to compare the data. And then you can use it to answer some questions. Again, I'm not going to do all of it, but we'll get a good start on it. Now the stem looks like this. Interesting. Curious how they were doing this. We'll look to see as low as 60 and as high as in the 90s. So we have a 6, 7. I'd like to make it a little bit bigger. For class 2, we look for 6s, and then we cross them out as we put them up. We have a 2. I don't see any more 6s. Then we go to 70s, and we look for the lowest 70. 5, 5, 6, 6 again, 8, so on and so on, 80s, 90s. I'm not going to do the whole thing. You could also do it on the left side, which is fairly rare. There'll be a definition somewhere around here that 6.2 is equal to 62. So you have to have that around. And then we would do things like look for the 60s on this. I see a 7 and an 8 for class 1. And that would be 67 and 68. Don't think I see any others. I'm going to do the 90s now just for the fun of it. 3, 3, 0, 0, 3, 3. Another 3, a 4, and an 8. And so on and so on. You could go and finish all this off. It's a little tedious, but it's a fairly classic way to show data. It does pop up on the ACT rarely, but sometimes. So we never did answer the questions, but you can go up here and say, now that I have this data, what's the highest and lowest? Which class scored higher? You basically just organize your data. You can do that by just putting all your data in order. This is why God invented Excel spreadsheets, but that's a story for another time. So, numbers used to describe data represent a middle value. Mean, median, and mode. Mean is your average. if you got a 86 and an 88 and a 90, we'd add them up, divide by 3, and get 88. So the mean is nice because it gives you your average score. And it works well if there's no outliers. For example, you usually get around an 88, but one score you got a 99. Congrats, that's great, your average will go up, but it's not really representative of the work you've been doing all year. If you have more high scores towards the end of the year, well, we would consider that data and talk about it and stuff like that. But the median means just line them up, 85, 87, 91, and you'd say, I just take the middle one. That's my median. And everybody always said to me, it's just the middle value. And I'd always say that seems like an average to me. The median always bothered me. But it actually makes good sense because if you have outliers, you live in the neighborhood where Bill Gates lives and you take all the average of your wealth, your average is something in the billions, but that's not indicative of what you actually would expect. Everybody was making, a couple $100,000 and bills off the charts. Well, a median will account for that much better. And remember, an outlier is just data that's just out there. I mean, it stands out. A lot of people just want to drop it from their data set, but you can't. You have to account for it. Mode is most common, 85, 86, 86, 91, 93, 86. And there's different places you might want to use a mode, but they're really kind of change with every time you're looking at some data. You'd really have to look at it and say, yeah, the mode's the best one here. Generally speaking, the median is used in real world data sets. So if you go here, which one best represents the data? The mean, we'd have to average up, and we'd have to use a calculator, 77 plus 78 plus 79, and go on and on and on. That would be a colossal pain in the butt. This one actually, yeah. So the mean would be about 88. The median is a classic trick. You just start crossing off the first and last. There was no 9. You get 82. And the mode is also 82. So like I said, you could say, oh, the mode's the best data. Well, it's also the mean. So in this case, it doesn't really matter. Which one's the best? It depends. The median does appear to be the best, but it really depends on what we're looking at, what the data represents. So here's work you can do if you want to pause the recording and run with it. It's the average age of U.S. presidents when they were inaugurated. I'm going to give the answers now. So again, if you want to pause this, the mean is 54.6. The median, there's actually two numbers in the middle. So when you have two numbers in the middle, you have to average them. 54.5. And the mode is 51. So either the mean or the median would probably be your best to represent the data. Mode isn't necessarily the best. But again, it depends. It depends on the data. It depends on what you're trying to accomplish. Now, simple probabilities is the number of favorable outcomes, which you want. Hey, you're flipping a coin, you want heads. So in this case, it would be number of favorable, what you want. And then this is just the total, anything possible. So, what's the possibility of rolling an even number on a die? Well, a die is a six-sided shape. It's got the numbers 1 through 6 on it. So when I say what's the probability, well, there's 3 evens out of 6 total. you have a 1 out of 2 chance of rolling an even number. Now I give you the classic, marbles in a bag or chips. Probability of drawing a blue chip is 7 out of 5 plus 7 plus 6, 7 out of 18. Red or yellow means 5 plus 6 out of 18. I have 11 out of 18 chance. If I pick 18 times, put them back in each time, I should get about 11 times I get a red or a yellow. And statistics, probability isn't perfect, but it can be pretty good. Oh, and I've actually forgotten that there's 10 green chips, so I'm going to ignore that just because I've already done all that math. Let's say not a red chip. Well, that's the same as saying a blue or a yellow chip, so it would be 7 plus 6 over 18, 13 over 18. Apologies, my bad. Just keeping things moving. Odds is a little bit hard. A little bit harder. And odds are what's used a lot in the gambling world, so it's good to know it. The odds on this one would be 11 favorable. That's the same. Nothing's changed. But it'd be 7 non-favorable. So it's the total minus the top. All right, this is total minus favorable. And that's just how odds work. You can go back and forth between them fairly easily once you see what's going on. So find the odds of rolling a number less than 3. Well, there's 6 total. Less than 3, there's 2 of them. So over 6 minus 2 is 2 over 4. Odds are 1 out of 2. Now, what does that mean? That's a good question. You have to think about it. It means that for every time I roll, there's a 1 out of 2 chance that I will roll 1 or 2. No, that's not what it means. It means there's 1 chance I'll roll 1 or 2, with 2 chances I won't. So it's really a 1 out of 3 probability. A lot of people say, well, why bother doing odds? And again, the gambling community uses it a great deal. Just be aware. Card is selected at random from a standard deck of 52 cards. What are the odds against selecting a number between 3 and 5? I don't know what against means. What are the odds of selecting a number? Well, if we're going against a number between 3 or 5, then my guess is that we have to use everything else. So I want to make sure I get this right. 3 and 5. Goodness gracious. So failure would be picking 3s and 5s. There are 4 3s, 4 4s, and 4 5s. So that's 12. There's 52 cards in the deck. So that's 52 minus 12. There's a 40, which we have to reduce. The odds are 10 over 3 that you will pick a card that's not a 3, 4, or 5. Weather forecast states that the probability of rain the next day is 40%. What are the odds? Probability is 2 out of 5. So odds 2 out of 3. One of the factors of 48 is chosen at random. What's the probability the chosen factor is not a multiple of 4? So we need the factors. 1, 2, 3, 4, 6, 8, 12. And I may or may not be doing this right. 24, 48. So we have factors. They all go into 48. Are you asking for the prime factors? Are you asking for the simple factors? We're going to go with that. What's the probability chosen factor is not a multiple of 4? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Not a multiple of 4. 1, 2, 3, 4. 4 out of 10, which is 2 out of 5. And the odds are 2 out of 3. Complex stuff. Finally, a square root in real numbers. What's a square root? Well, it looks like this. And it's 2. It means something squared equals under the radical. Horrible definition, I know, but pops up so very, very, very often in mathematics. Once we just get used to it. So, I guess, you could say it's an equal factor. 2 and 2 both go in, and 2 times 2 is 4. Equal factor of the number. I don't like it. Anyway, square root of 64 is 8. Somebody slapped a negative out front, so it comes along for the ride. Square root of 4 is 2. Square root of 9 is 3. Somebody slapped a plus minus. And square root of 0.81, I believe, is 0.9. I'd have to check that one out. Yeah, it works. Square root of 12 is 3 point something. I don't know how to do that without a calculator. Now, I can do guess and check, which would take a fair amount of time. I do have a calculator handy, so I'll just run over and do it, but it's a good example of, why we use some of these devices these days. 3.46. Well, why did I go to 2 decimals? Yeah, it's random. I could have gone 3.5. Could have gone to 3.64. What is different about the solution to D? It's what we call irrational. Square roots don't repeat. Rational numbers repeat, have patterns. Irrational numbers, which is part of the real world, just goes on and on and on. It cannot be expressed as the ratio quotient of 2 integers. Put them all together, you get real numbers. So you have all this, we'll call that the irrational numbers. You have natural numbers, whole numbers, integers. Yeah, Z stands for integers. And rational numbers. That's not, yeah, we can use R. Irrational numbers, put them all together and we get the real numbers, which looks like an R with 2 pegs on the left. Now, name the set or sets of numbers to which each real number belongs. Well, this is a rational number and it's a real number. This is 11, so it's a natural number, a whole number, an integer, a rational number, and a real number. This is just a real number. And I could say it's irrational, but if it's not one of the other ones, we kind of know that. This is a rational number and a real number. My bad. It actually reduces to -4 and an integer. Yeah. There's a lot going on here. Graph the solution set for real numbers. Put this to 0. X is greater than 2. So this is 2. It's an open dot. Goes further that way. Might have seen it like this too. Lots of different ways to do it. It's just that you graph a solution set for real numbers. If this said greater than or equal, this would be a closed dot. But it doesn't. Write these sets of numbers in order from least to greatest. So, root 30 is something like 5.6-ish. I really don't know. This is 5.4. This is 13, and this is some decimal 0 point something. So if I'm going to put them on a number line, I'd plug them all in. But if I'm just going to order them from least to greatest, then 1 over root 30 is my smallest. 5 4/9, my next biggest. Root 30 and 13. I'll go in that order. Now I feel like I may have messed up here, so I'm going to go check on my calculator. Okay, 5.4 is correct, and the square root of 30 is 5.5, which works, just slightly off in terms of my guess. I believe that's about it, and that is a lot of material, so definitely do some practice problems, get comfortable with it. Good luck, and happy mathing.